has a Poisson lambda distribution, then the mean of x is lambda. The mean of x is lambda. We can prove that. Okay, this is nice because it means that, well, the mean of a Poisson lambda is just lambda. It's just the parameter. It's easy to remember. Okay, and I'm going to remind you too that Poissons are discrete random variables. Okay, they model the discrete number of things that occur in a continuous time or continuous space, but they are discrete random variables. Okay, so with that in mind, I'm going to use a summation sign. Okay, 0 to infinity, right? That's how we'll get the expectation here. And now I'm going to replace that probability part with the probability mass function that I know that we need, e to the negative lambda times lambda to the k, or k factorial. Right. Feel free to pause this and work it out yourself. That would be excellent practice. Excellent practice. Now, first thing I'm going to notice is that, hey, I can actually start this sum off with k equal to 1, right? Because if k equals 0, then this first term is 0. So let me just do that. That might help us here. Oops, missed my k. All right. And now let's see. I see that I can actually cancel this k with one of the k's in the bottom. Okay, so I'll have k minus 1 factorial at the bottom. And let's see, what else can I do? Oh, look at this. So I can pull e to the negative lambda outside the summation sign. And I can also pull a lambda out of the summation sign. I'm going to do that because it turns out I already know the answer. I already know the end result, right? It's given to us in the problem. It's given to us. The expected value is lambda. So I'm going to go ahead and pull that out and know that here's the answer. Whenever you're given the answer, then that's big fat help, isn't it? Okay. I just need to show that all the rest of the stuff that you multiplied goes to 1. All right, so then I'm just going to be left with k equals 1 to infinity, lambda to the k minus 1 over k minus 1 factorial. Oh, but hey, look, k equals 1 here. This summation really starts off with all this stuff being 0 factorial, right? And this being a 0 in the exponent. I could make a change of indices there. Maybe I'll change back and go from 0 to infinity. Here I'm just, I'm going to say j equals k minus 1, okay? So that's going to be lambda to the j over j factorial. But hey, you should know that this sum is actually e to the lambda, right? You've seen that in probably a calculus course or something. So the whole thing is just lambda. Excellent.